Okay, this is the Math 1113 Zoom meeting for February 9th. And we're covering sections 5.3 and 5.4 this week. Section 5.3, practice problems. A lot of different sections in this. And in section 5.4, practice problems 5 to 37. Not for a grade, but we'll have quiz 4 on Friday that will cover them. WebAssign personal study plan, problems 1, 2, 3, 4, and 5 only in section 5.3. Problems section 5.4, 1A, B, and C, 2, 3, and 4 only. And I believe that's 9 problems. So just email me the percent of these 9 problems that you get correct. I emailed out 5.3 as a lot of formulas. And to try to explain them all, and then still get to some example problems here is a little overwhelming. So I'll show you the ones I'm talking about. This is the start of them, how they relate the sine of an angle to coordinates. And then sines of the triangles and reference angles, and finally formulas. And then the formulas they show you finally are here. And so the very basic one is this one, sine squared plus cosine squared theta equals 1. Okay, so I hope you watch our separate video. Please watch the separate video on formulas. I emailed out. Remember, there is a 4-digit embedded code. Email me the code for 5 points, extra credit on test 2. Okay, we'll just start with the very first ones. Page 457, just to show you some of the really simple formulas. I won't explain those other formulas. I'll let that other video do that. But you start with your standard axes. We've mentioned this before. Draw a ray up, swing it up, an angle theta, radius r, drop your vertical. This is the x side, this is your y side. And the sine of that angle, opposite, this is adjacent, this is hypotenuse, is y over r. All right. Unit circle on a unit circle, r equals 1. So that means sine theta is just equal to y. So the sine of any angle gives the y coordinate at that angle. Cosine of theta, the other basic one, is equal to adjacent over hypotenuse. Again, with r equal 1, cosine theta is equal to x, or x equals cosine theta. Up here, I probably could have switched it around with y equals sine of theta. So the cosine of any angle gives the x coordinate at that angle. Okay, and finally, the tangent of angle, another thing, opposite over adjacent equals the y over x gives the ratio of the legs, y over x. Of course, then you can switch them. Maybe I should put it up here. Your cosecant theta is 1 over y. Just flips them. Your secant theta, 1 over x. And your cotangent theta flips the tangent x over y. Okay, and that is what they're showing you on these diagrams or formulas. Okay, then they talk about signs of trig functions. In each quadrant. Okay, so quadrant 1, x positive, y positive. This means sine of x is cosine of theta positive, y is sine of theta positive. Tangent theta, their ratio is positive. Everything positive. Quadrant 1. But you go to quadrant 2, x negative, cosine theta negative. Y is still positive, sine theta positive. But tan theta, their ratio will be negative. So they say y or sine theta positive. Cosine the x being negative, and when you divide them, positive over negative gives you negative. Quadrant 3, now your x is negative, so cosine theta is negative. Your y is negative, sine theta will be negative, but your tangent is positive. Negative over negative is positive. And finally, quadrant 4, x is positive, so cosine theta is positive. Y is negative, sine theta then is negative, and your tangent is also negative. Because you got a positive over negative gives you a negative. And so they just explain all that, and they want you to find signs. A reference angle. Is the positive acute. I think I'm getting fainter and fainter. Angle to the x-axis. So quadrant 1 has their own. If I call this 45 degrees and I say find theta ref, well, that's easy. 45 degrees. It's its own reference. All right. If I come here, let's say up and do 60 degrees, or 120 degrees, let's say 120 degrees. Well, its reference, this will be theta ref, and it will equal 60 degrees because your 120 plus your 60 gives you your 180. You can almost do them in your head. I can write down the arithmetic, but you can almost do it in your head if you can visualize it. And they'll have you do this in radians. 120 degrees is the same thing as 2 pi over 3. Find theta ref. Theta ref will equal pi over 3. Now that's obvious to me, but this is pi. And with the common denominator 3, that's 3 pi over 3. So you want to see the arithmetic, your theta ref will be 3 pi over 3, subtract 2 pi over 3, giving pi over 3, 1 pi over 3. Okay. It's not a hard thing. We'll have you do it. And finally, the formulas. I don't want to write all of them down because I wrote that other video. I'm going to assume you know them. I'm just going to explain the first one. This is the granddaddy identity. Granddaddy identity. Dent to T. Okay. Again, R theta drop. You have your y leg and your x leg. And we said your x leg squared plus your y leg squared has to equal r squared. Again, set r equal 1. And we said your x was cosine theta and your y was sine theta. That gives you cosine theta plus sine theta equals 1 squared, or 1. Now this is perfectly legal, but it's not really the way they usually write it. For some reason, they like to write the sign first. The sign is first on your calculator. It's the y leg, but it's the first thing, on your calculator. They list sine, cosine, tangent. Now that's your y leg, your x leg, and the ratio of y to x. So they usually put it this way, that a sine, and they write the square this way, but that's not the way you can punch it on the calculator. You can't punch it this way on the calculator. Cosine squared theta then equals 1. All right, just to give you some confidence in this, I'll just make up a crazy angle, 111 degrees, 110 degrees since I wrote 110. Okay. Now, the way you got to punch this, you'll have to punch this. I'll write sine 110 degrees squared plus cosine 110, and I better get 1. Let's see if I'm in degree mode. I am. Parentheses sine 110 squared. Let's see, I needed a parentheses before I squared it. Okay. Plus parentheses cosine 110 squared, drum roll, 1. The thing is, I can switch it to radian mode. I'll get the same thing because the sine of 110 radians plus the cosine of 110 radians will still equal 1. But I have no idea where 110 radians is on the circle. I don't have to know. Switch it to radian. Oops. Enter. Okay. Call it back. Now it's 110 radians. Doesn't matter. The sine of any angle plus the cosine squared plus the cosine of any angle squared always equals 1. You understand that, you understand about 90% of trigonometry. It's amazing how many things come back to that. And by the way, there are all kinds of variations, and there's no way you can memorize them. Variations. A sine squared is 1 minus a cosine squared. By taking, sine squared, cosine squared, and subtract cosine squared. Subtract cosine squared. So there will be times when you'll want to replace a sine squared with 1 minus a cosine squared. A cosine squared is 1 minus a sine squared. Okay, I'm going to leave the rest of it to that other video, and we'll just charge into some of these problems. And when I need other formulas I haven't covered this video, I'm going to refer to the other video and to this page, and you can see what, where they come from. Starts off page 54, 464, with finding reference angles. In fact, 120 degrees, I've already done 120 degrees. I'll do 5B. 200 degrees, find theta ref. I always picture this. Now, once you get good enough, you might be able to do the picture in your head, but tough to see neurons floating around my head. 200 degrees, you got to be able to picture where quadrants things are in. See, this is 180 degrees. So 200 is 20 more. It's bigger than 180. The space back to the x-axis is theta ref. Number's easy enough, you can obviously tell it's 20 degrees, but I'll write it out. It's 200 degrees, subtract 180 degrees, and there you are at 20 degrees. Remember, it is always positive in between 0 and 90. Why don't we try a crazy one like a 10, 7B. Page 464, 810 degrees, find theta ref. Okay, where the heck is 810? I have no idea. That's why they did the thing about coterminal angles. So it's bigger than 360. I'll go minus 360. $450. Still don't know where 450 is. Minus 360 again. I'm at 90 degrees. Right up here. So this would be theta usually squared off if it's a 90-degree angle. So theta ref, 90 degrees. Okay, let's see. What about a different system? Why don't we try 11A? 5 pi over 7. Find theta ref. Okay. Now, remember this is 0. Got to be able to work in a system like this. This is pi. With a denominator of 7, that means this is 7 pi over 7. Whatever number that is, that's your denominator, and that's a whole 1, so they match. This is halfway there. Well, half of 7, that's not real even. That would be 3.5 pi over 7. 3.5 being half of 7. Whatever this is half of it. Well, you're at 5 pi over 7. That's bigger than 3.5. It's between 3.5 and 7. 5 pi is somewhere in here. 5 pi over 7. Half, there's the 5, there's the 7 pi over 7. This is your theta ref. Should be able to do it in your head, but I'll write it out. You take 7 pi over 7. Subtract 5 pi over 7, getting 2 pi over 7. It makes perfect sense to me. I want to do a crazy one like 11b. How about a negative 1.4 pi? Negative 1.4 pi, find theta ref. Okay, I would convert that to a full decimal. 1.4 pi. 4.398, negative 4.398. Okay, going in the negative direction this time. I always come over here to have full pi, negative pi, that's negative 3.14, or negative 1 pi. So you theoretically could leave it separate just like this. See, I'm at negative 1 pi here. Okay, well, I'm in further, how do I know I'm not further on past here? Well, that would be a negative 3. Remember, this is positive 3 pi over 2. So going this direction, you'd be at negative 3 pi over 2. If you want the decimal for that, negative 3 pi divided by 2, negative 4.71. So you would come to negative 4.398 just before hitting that. Yeah, so it's just before you hit this. That is your theta ref. Don't let all these negatives throw you. You might get your signs off and everything. Your theta ref is always positive. Theta ref, just make it 4.398, subtract pi. That's the space here. The negatives don't matter. 4.398 subtract pi. 1.256. The book may have some sort of fraction of pi on it. In fact, this was 1.4 pi, right? You could have done it that way. You could have done it 1.4 pi subtract pi till that's 1.4. No, early in the morning, my fault. That'd be 0.4 pi. So there's a check. These should be equal. Drum roll. 0.4 pi. Yeah, there you are. I had pretty close to 3 places. We got a little round off here, but yeah, you can do it either way. All right, what about values of trig functions? Find the exact value. This is pretty simple. Punch them on the exact value they want off the calculator. So 13. On page 465 now, exact value. You have cosine of 150 degrees. This is the x coordinate at 150 degrees. So I hope you know your unit circle values. 150 will be 30 short. Reference is 30 of 180. There's your 150. The long side is negative root 3 over 2. Short side's positive a half. Your cosine, 150 degrees, would equal negative root 3 over 2. See the useless stuff I have in my head. If you want to check it, you can punch it both ways. Calculator, check. All right, you want degree mode. Cosine 150, negative 0.866, negative square root of 3. There you are, negative 0.866. But this is exact. A lot of trig is they zero in on certain specific values. Remember, that's an x. They call it the first quadrant equivalent of 30 degrees. 30-degree angle, your y side is half your hypotenuse. Remember, hypotenuse is assumed to be 1. What about one like tangent 23, tangent 50 degrees. This is the ratio you're finding of y to x at 750 degrees. All right, well, again, I got where the heck is 750 degrees? So I'm going to get back to the first quadrant, or once around anyway. 750 minus 360, 390 degrees. Okay, minus 360 degrees again. 30 degrees, a 30-degree equivalent. 750 is at 30 degrees. Up. Your long side, just like up here, it's just positive root 3 over 2. Your short side's a half. Your tangent will then equal the y divided by the x. Don't really have the tangents memorized, except at 45, they're ones. 1/2 times 2 over root 3, which is 1 over root 3. And they usually rationalize it over root 3, making it root 3 over 3. If you want to see it punched, make sure I'm in degree mode. Yep. Tangent 750. 57735. Root 3 over 3. 57735. All right. 37, find which quadrant an angle lies. When they give you that sine of theta less than 0, cosine of theta less than 0. Your sine of theta is a y, cosine theta is your x. If they're both negative, it's got to be quadrant 3. Not a lot of work to show. They just want you to associate a sine of theta with the y coordinate, cosine of theta with an x coordinate. You translated the y and x, and you know which quadrants y and x are positive and negative. It's pretty obvious. Okay, 41. Write the first trig function. 3-4, problems 5 through sheet. Okay, 5 through 55 odd. Okay, 5 through 55 odd. All right, this gets a little tricky. They give you a tan theta, comma, cosine theta. Okay, this is first, second. This is a little tricky to interpret their directions. Theta in quadrant 3. Write first, that means tan theta, in terms of second, which is cosine theta. Okay, you're going to need your formulas. I call them formulas, identities. Okay. Which means, first in terms of second, means you want your answer to look like tan theta equals, and over here you have cosine theta. So you may have other things as well. tan theta. Okay. There's several ways to do this. Let's see. I don't think they directly want sine theta over cosine theta. They really would like only cosine theta here, and you might have other numbers. Okay, so you got to kind of pick a formula that gives you the closest way, or an identity. I'll refer back to them. All right, you got tan theta there and cosine theta there, but they usually don't want another function. All right, you've got tan squared plus 1 is secant squared. Again, I explained in that other video where they get that. And you can turn secant into a cosine using this. So I'll start with tan squared equals secant squared. Okay, and tan squared is then 1 over cosine squared. Okay, tan squared then, 1 over cosine squared minus 1. And tangent theta would be plus or minus a big square root. You're going to take a square root on both sides. Cosine squared theta minus 1. Now the book may get a common denominator on this. Now to choose the plus and minus, that's where the quadrant 3 comes in. Tangent theta positive in quadrant 3 because it's the ratio of the legs. Y is negative, x negative, divide them, you get positive. Positive. Now the book more than likely will get a common denominator. You don't really have to do this. I need cosine squared, so it would be positive square root 1 minus cosine squared theta over cosine squared, which would be, I'm about run out of room. I guess I'll come up here. 1 minus cosine squared theta over cosine. I can look that up. 5.3, it was 41. Yeah, there it is, except they got it negative. They didn't say quadrant 3, didn't they? Yeah, just positive in quadrant 3. Oh boy, looks like a mistake to me. I'm getting the square root of 1 minus cosine squared theta over the cosine. Should be positive. Quadrant 3. And it's negative in quadrants 2 and 4, not 3. I see mistake. Okay. Go to 47. You try to find values of trig functions from the given information. Sine of theta is a negative 4/5. You're in quadrant 4. Okay. You got to picture this. Here's quadrant 4. Go out and vertically back. There's your right triangle. Your theta really is all the way around, but this is the theta ref. Sine theta, there's two ways you can do it. You can use it as a direct y coordinate and put the -4/5 here and put 1 here. I prefer to go ahead and make this the opposite, this the hypotenuse. Now, if you can figure out your x leg here, x squared plus a -4 squared will equal 5 squared. Do it this way, you don't have to mess with fractions. X squared plus 16 equals 25. Your x squared equals 9, and x would be 3. Now, if it's in other quadrants, it could be -3, but x is positive in quadrant 4. So there's your triangle labeled, and you can get your first row. Here's your answer. Sine theta is your -4/5. You can do the cosecant. Cosecant theta is -5/4. You don't have to leave the negative on bottom. The negative can go either, you can stay on top. It's the same thing. Cosine theta is 3/5. Secant theta, 5/3. Tangent theta, -4/3. Cotangent theta, -3/4. Remember, this is opposite, adjacent, hypotenuse. So your cosine is 3/5. Tangent theta is opposite over adjacent, -4/3. It means you're a little bigger than 45. Remember, at -3/3 would be -1 and 45. If you're bigger than 1, you're going to be bigger than 45 degrees. All right, something like 55. Theta equals pi/3. Find sine of 2 theta versus 2 sine of theta. This actually is, compare the two, and it illustrates a very important part of trigonometry. That means you're going to get the sine of 2 pi/3 versus twice the sine of pi/3. Okay. You compare the two and something very interesting happens. At least it is fascinating to me. All right, draw out 2 pi/3. And your reference will be pi/3. They give you 3 pi/3 here. And your sine is your y coordinate, and it's √3/2. This is equal to √3/2. And you can punch it in radian mode and show it's the same thing. Come over here and do pi/3. Pi/3 here. And your y coordinate is the same thing, √3/2. So your reference is pi/3, which means the sine of 2 pi/3 equals the sine of pi/3. I can punch it and show you radian mode if you want to see it. You could actually do a degree mode, 2 pi/3, but we'll stick to the standard thing. Radian mode, sine 2 divide by 3, and sine pi divided by 3. Same thing. The 2 doesn't seem to make any difference. I've met people that just blows their mind. What do you mean? How can they be the same thing? They're the same thing because you have doubled the angle around. You start with pi/3, you get that y coordinate, but when you swing around and double the angle, you come back to the same spot with the same y coordinate. I find that fascinating. At least it is fascinating to me. Now, the answer here is the sine of pi/3 is equal to this. So you get 2 times √3/2. And on this, the 2's cancel, and you just get a √3. Whereas over here, you get a half of root 3 because they put the 2 outside. They're trying to compare where you stick the 2. So you leave the 2 inside and you get a straight, you get a half of a root 3 over 2, put the 2 outside. This directly equals this, but then you're doubling it and you get a full root 3. All right, that pretty much finishes 5.3. So let's charge into 5.4. And we're at the bottom of page 467. Inverse trigs. And they give you a whole lot of gibberish here about this. And let me try, and rather than just write down the gibberish and you have everybody go, whoa, what the, okay. Let me just, I'll just charge into example 1A and try to explain, what's going on, and maybe that can lead us into the gibberish formulas. Example 1, part A. I want you to take arc sine of the square root of 3 over 2, find the exact value. Now, what happens is you can call this an angle. And if you do the inverse, we did inverses so back in chapter 4. Remember, these things are paired with their inverses. So if you can see, you get the glare off. Sine with, and they put this -1 notation up to denote inverse. So undoes sine. This is read inverse sine. Sometimes they use the word arc or a little label arc sine. So if I do a sine of theta, then I'd get a sine of an arc sine of a root 3 over 2. And these undo each other, which means sine of this angle that I don't know is equal to root 3 over 2. So I'm basically finding the angle with y coordinate root 3 over 2. How do I know it's a y coordinate? It's a sine. Sketch it out. Root 3 over 2 with the y coordinate. That means the x coordinate's a half. This has got to be 60 degrees. But they usually are using radians, which means pi over 3. So the answer, theta equals pi over 3. I can punch it, or I can show you. Pi over 3. Okay. Let me do a few more before I try to bring in their gibberish, because the gibberish is important because they're going to give you some numbers you can't do. And you can't do them because they're out of domains. So let me I keep losing the assignment. There it is. All right, we're doing 5 to 37 odd. We'll do a few more here. Okay, so page 470, this is 5.4, page 472. Try to say problem 5A is the very first one. Arc sine of 1. Same idea. Write out the steps. Arc sine of 1. Sine theta equals 1, because sine theta here will undo this to give you 1. Well, where are you, or where is your sine theta 1? Well, it's up here. Coordinate 0, 1. that angle would have to be pi over 2. Pi over 2. And you could punch it in radian mode. Sine of pi over 2 would equal 1. It would not work in degree mode. Sine of pi over 2 degrees would be like 1.57 degrees. Would not be some crazy decimal. All right, why don't we try 7a? I'm doing arc. Let's switch to an arc 7b. An arc cosine of a negative root 2 over 2. All right, you'd have, again, this is a theta equals cosine of theta equals negative root 2 over 2, because your cosine here undoes cosine here, cosine theta. All right, where do we get? This is an angle with x leg, negative root 2 over 2. Well, x leg's negative or this direction. Okay, if you remember, it would be at 45 degree equivalent, which is pi over 4. So that would have to be 3 pi over 4. And this would down here have to be 5 pi over 4. They would both have the same x leg, 45 degree equivalent. This would be a pi over 4. Bigger than pi, see this is 4 pi over 4. So you'd be a pi over 4 bigger than pi over 4 less than pi over 4 that direction. Which is it? 3 pi over 4? 5 pi over 4? And the answer is, or the winner is, 3 pi over 4. Why? It is in the, as we call it, domain or range of arc cosine. And that's what they're trying to show you. The range of arc cosine is 0 to pi. They do this again in chapter 6 a lot more thoroughly. To me, this is kind of out of order explaining what they're doing, because you need graphs to explain this, and you got to bring in vertical, horizontal line tests, and et cetera. And they're really not explaining any of that here. To me, this is kind of out of order. They're bringing in stuff they just really have not explained. And they do a much better job of explaining it when they show you graphs of functions in chapter 6, and then they bring this back again. So I don't want to get into it too deep. Because they have to show you graphs to explain it, and they haven't done graphs. Number 9 can be punched on the calculator, so it's pretty easy. Arc sine of a point 30, 5 places on calculator. And they do say radians. So, boom. Mode, radian, I am in radian mode, and it's just easy as punching second sine, 0.3. 0.3064, that's not a negative on my calc, I got a blip on my screen, that's a 0.3047. Okay, now this has meaning. Okay, go back to the other one. Arc sine of your root 3 over 2 might be more obvious. This is your y coordinate. Your answer is the angle. And remember that worked out pi over 3. So this is your y coordinate. This is your angle. And it's simply saying 0.3 y coordinate So up here, 0.3. Your angle is 0.3047 radians. The numbers look really similar, and this is your y coordinate. So you have found the angle in radians with a y coordinate of 0.3. Remember, your hypotenuse is 1. It makes perfect sense to me. Okay. So now they're going to give you different numbers like in 17. And they give you a 10 and a 6 and a theta here. Find theta. You're saying in degrees, one place. Rounded to one place. Well, again, you're given opposite over hypotenuse. So that would be a sine of theta, 6 over 10. The theta would be the inverse sine of 6 over 10. I'll switch back to degrees. Inverse sine, 6 divided by 10. 36.8698. They did say one place, so we'll make it 36.87. That'd be called 9. Oh, don't leave off the circle. That's degrees. 36.9 degrees. All right. 23 gets a little more involved. Find all angles between and 180 degrees that solve sine theta 2/3. Round your answer between 0 degrees and 180 degrees. Okay. Well, step 1, your first angle. You'd get that from a direct inverse to this, which would be an arc sine of 2/3. And they want this in degrees. And I am in degrees. Second sine 2/3. 41.81 degrees. They did say one place. We'll call that 41.8 degrees. Okay. Where's the other angle? Because that's all the calculator is going to give you. This is the only angle in range of arc sine. The calculator will only give this angle. Will only give this angle. Where's the other angle? Draw a diagram. Okay, 41.8, you locate that. That's clearly first quadrant. And we're saying that its y coordinate is 2/3. Where else are you going to have a y coordinate of 2/3? Clearly over here. The reference is 41.8. In effect, the calculator gives you the reference angle. Degrees. The other angle is that angle. Other answer answer is 180 degrees, subtract 41.8 degrees. 138.2 degrees. You can do a check. Sine of 138.2 degrees had better equal 2/3, or the decimal for 2/3. It'll be close, there'll be some round off. Sine 138.2, 666. This is 0.666666 repeating, and I'm getting 666,532 or so. So to three places, you're getting the same thing, and that is your y coordinate at 138.2 degrees. So your two answers are 41.8. Two answers for sine theta equals 2/3. Theta equals 41.8 degrees, 138.2 degrees. They both have the y coordinate of 2/3. All right, just a couple more sections. Why don't we try one like 29? Find exact value of cosine of arcsine of 4/5. You got to understand, this is an angle. I can call it theta is arcsine of 4/5. Sine of theta then equals 4/5. Draw a triangle. 4, 5, opposite over hypotenuse. Can you tell this side is 3? This angle is arcsine of 4/5. The cosine of arcsine of 4/5 then, can you tell, is 3/5. That'll be 0.6. And you can punch it. Let's see. Should we be in, probably safer to be in radian mode here. Cosine, second sine of 4/5. 0.6. It's magic. Okay. I'm going to try one like 35 where they do it in X. It's harder to check this. Find an expression or a formula in X. Find a formula in X. And you have, it's the same idea, they just give you an X. It's the same idea as 29. It's a cosine of arcsine of X. Stick that over 1. See, they labels according to the sign. Theta equals arcsine of X, sine theta, X, and you can stick it over 1, and that's your opposite, and this is your hypotenuse. So you got X, 1. Now, in your head, you want to, if you want to call this U, so I don't know. It's not another X again. The legs aren't equal. U, well, just call it U. All right, so U squared plus X squared equals 1 squared. U squared equals 1 minus X squared. And U is the square root of 1 minus X squared. So that's the formula for the leg. This is adjacent. This is hypotenuse. HY, hypotenuse. So your cosine of an arcsine of X is the square root of 1 minus X squared over 1, which is just the square root of 1 minus X squared. Now from 29, making the x was 4/5. You had cosine of arc sine. Remember, we got 0.6. So now they had you find a general formula for it. Should be able to plug 0.6 in this. I'm sorry, 4/5, which is 0.8 in this, and get out 0.6. Let's see. 1 minus 4/5 squared. I better get 0.6, or I'm preaching lies and I should just go quit. Let's see, square root 1 minus parentheses 4 squared, close parentheses again. Let's see if that, drum roll, bingo. So here's a general formula for it. All right, well, that pretty much covers 5.4. So we'll have another Zoom meeting on Friday for anybody who has any questions, and we'll just close it up and end the meeting. If anybody watched this far, please watch the video. Get 5 points extra credit. Explains a lot more about those formulas in depth. All right, hope you all have a good day. Thank you.